Okay, so this video is meant for my Concepts of Algebra 2. We have a test on Thursday, big test, and I'm going to do 2 word problems and a 3x3 system to try to get you prepared for that test. Okay, so here's the first word problem. It says that the perimeter of a rectangle is 30. The width of the rectangle is 3 more than double the length. Find the dimensions of the rectangle. Okay, the question tells you what the variables are. Here is the question. So here is the question. Find the dimensions of the rectangle. So we need to know that the dimensions of a rectangle are typically the length and the width. So x is length and y is width. Okay? Now, I see this word perimeter. So again, if you have a rectangle, let's label the lengths x, the widths y. The perimeter is when you add up all the sides. So it would be x and y, or 2x plus 2y. This is going to give us our first equation, the perimeter equation. Now, we're going to use 2x, 2 times the length, plus 2 times the width. That gets us the perimeter. But we're not going to use p, we're going to use the actual perimeter. The perimeter is 30. There we go. There's the perimeter. The other equation comes from this second sentence. Comparing the length and width. Compare your sides. And what it says is the width of the rectangle is 3 more than double the length. So here we go. We need to remember that is means equals. So I'll put my equal sign right here. What is to the left of equals? The width. The width is y. To the right is 3 more than double the length. Well, 3 more means plus 3. And double the length means 2 times the length, or 2 times x. So when I put this together, I'm going to double the length and then add 3 more onto it. And here is my 2 equations that I'm going to do my system of equations with. Now, this is beautifully set up for substitution. So I'm going to substitute. So I'm going to scroll down. Here's my 2 equations. I'm going to take that first equation. Right? This right here is solved for y. So in that first equation, I'm going to put 2x plus 3 in for y. 2x here plus 2 times what y is equal to. 2x plus 3 equals 30. This is classic substitution. And now, distribute that positive 2. So the 2x stays the same here. This becomes a positive 4x. This becomes a positive 6. That stays 30. This right here, 2x and 4x, is 6x plus 6 equals 30. I will subtract 6 from both sides. 6x equals 24. And divide by 6. And I get an x value of 4. So that is going to be the, I believe, the length. Right? If I scroll up, that's the length. The length is 4. Now, to find the width, or y, I'm going to recopy that equation, y equals 2x plus 3. That's the equation I solved for, or was solved for earlier. This x value is going to go in for x, right there. Y equals 2 times 4 plus 3. Y equals 8 plus 3. Y equals 11. So this rectangle has a length of 4 and a width of 11. 4 by 11. Okay, here is problem 2. Problem 2 says, on the first night of a carnival, 300 children and 175 adults bought tickets. The total revenue from ticket sales was $11.50. On the second night, 520 children and 350 adults bought tickets. The total revenue that night was $21.80. What are the admission prices to the carnival for a child and for an adult? Find the question. This is where you get your variables from. So, what are the admission prices for an adult and a child? Or for a child and an adult. So, X will be the admission price for a child, and Y will be the admission price for an adult. Okay? That's what we'll do. Admission price for a child, admission price for an adult. So, the two equations that we're going to create are coming from the two nights. So, night 1, first night, and 2 is the second night. Here's where our two equations come from. So what happened on the first night? 300 children came, 175 adults came. The total that they got was $11.50. So if 300 adults came, or 300 children came, each of them paid X for their ticket. 175 adults came, each of them paid Y for their ticket, and total they made $11.50. Now the other one, the second night, 520 children came, so 520X. 350 adults came, 350Y, and that revenue was $21.80. And here's our two equations. Okay? So now we need to create, do this system of equations. Now, I look at these numbers, these are huge numbers. Oh my gosh. But, find the common multiples. If I look, the Y's are smaller, and we wouldn't make this impossible for you guys. So watch this. 175 becomes 175, 350. There it is. 350 is the common multiple of 175 and 350. So in this situation, the bottom one's already a positive 350. You don't have to multiply by anything. But the top, we need to figure out, what do I multiply 175 to make it 350? And I would like it to be opposite. That'd be a negative 2. 2 times 175 is 350. Make it negative by multiplying by a negative. Okay, so I'm going to scroll down here. We're going to multiply the top equation by negative 2. That gives me negative 600x minus 350y equals negative 2300. The bottom equation stays the same. 520x plus 350y equals 2180. Draw the line and add. That's negative 80x. These cancel. Over here we get negative 120. Divide by negative 80. Divide by negative 80. X equals, and I believe we get $1 or 1.5, right? Yes, 1.5. And it's okay in this situation, because think, you're getting an admission price. Admission price, this is $1.50. That's okay. That's a good number. So now take this $1.50, this 1.5, plug it into X in either equation. I'm going to choose the bottom one because it is smaller numbers. 300X plus 175Y equals 1150. This value of X goes here. 300 times 1.5 plus 175y equals 1150. 300 times 1.5 is 450 plus 175y equals 1150. Subtract the 450 from both sides. This gets you 175y equals 700. And divide by 175. You scroll down. Divide by 175. And we get y equals 4. So X was the children, Y was the adults. So it's $1.50 for children, and it is $4 for adults. And there's your solution to this system of equations. Okie doke. Last problem coming. Okay, here's our last problem. Here we're going to do this 3x3 systems of equations. Okay, so first thing we do, step 1, we look for which variable to eliminate, and that's going to be y. If you look, y is the only variable with a 1 in front of it, and specifically it's this equation. So we're going to write that equation twice. 2x minus y plus 3z equals 4. 2x minus y plus 3z equals 4. Then the first and third equation, one goes here, so let's put the first equation here, and one goes here. And now we need to eliminate the y. We need to get the y to go away. So what do I do here? I'm going to take this top equation. This is already a positive 2, so I'm going to make this a negative 2. Well, it's already a negative, so just need to multiply by 2. 1, 2, 3, 4 times 4x minus 2y plus, 6z. Don't put that 8. It's a 6z equals 8. 4x minus 2y plus 6z equals 8. I just doubled everything. Recopy the second equation. Let's scroll down just a little bit. And now we add. This is 7x. This is 10z. And that's 19. Now come over here. Do the same thing. Oh, this is a new equation. We want to make sure we identify that as a new equation. Come over here. I want to make this a positive 3 to match that negative 3. So multiply by a negative 3. That'll make this turn positive once, twice, 3, 4 times. Negative 6x, positive 3y, negative 9z, and a negative 12. We'll bring that second equation down because we're not going to multiply by anything. We have the situation we want with the y's. And now we add. This is negative x. The y's cancel. This is negative 4z, and that's negative 13. This is, again, one of our new equations. So step 1 is done. Okay, let me scroll down. Step 2. Okay, we're going to eliminate our second variable. Let's write these two new equations on top of each other. 7x plus 10z equals 19. Negative x minus 4z equals negative 13. I look at these two equations and I say which variable is the easiest one to get rid of, and that's this x. This x in the bottom I can make become anything. So take this bottom equation and multiply by a 7. That'll make this a negative 7 to counteract with the positive 7 up top. So we get a negative 7x, a negative 28z, and a negative 91. The top equation remains the same. 7x plus 10z equals 19. I have the situation I want with the x's, so they cancel. Negative 28 and 10 is negative 18z. Negative 91 and 19 is 72. To find z, divide by negative 18. Z is negative 4. There is your first. Oh, I'm sorry. This is a negative 72. I apologize. So it's negative 18z equals negative 72. Divide by negative 18, and this is a positive 4. Okay, make sure we have that right as a positive 4. Z is positive 4. So now, step number 3 is to find, and we need to find x and y. Well, we have these two equations here that have x and z. Plug z into one of those two equations. Let's choose the bottom one because they're simpler numbers. Negative x minus 4z equals negative 13. Plug your value of z in for, or plug your value of z in for z. So that's a 4. Negative x minus 16 equals negative 13. Let's add 16 to both sides. Negative x equals 3. And let's divide by negative 1. And x equals negative 3. So now we have x and z. Now I need to go back up to the original problem, and I need to say, okay, that was the boxed equation. 2x minus y plus 3z equals 4. I'm going to write that down. Let's see if I remember it. 2x. Nope, I don't. Got to go back up. Minus y plus 3z equals 4. 2x minus y plus 3z equals 4. And I plug in z and x into this equation. 2 times negative 3 minus y plus 3 times 4 equals 4. And I simplify. Negative 6 minus y plus 12 equals 4. The negative 6 and 12 make a positive 6. So this is negative y plus 6 equals 4. I'm going to subtract 6 from both sides. Negative y equals negative 2. Sorry for the slant. And now I'll divide by negative 1. And y is 2. So it's an ordered triple, the answer. Negative 3, 2, 4. Okay. So hopefully you think these 3 problems helped you, and you come to that test on Thursday ready to go. I would suggest you watch the other video too on graphing, substitution, and elimination, or linear combination. Thanks for watching.